Hello, this is Nick Andre, your at-home instructor, welcoming you to another screencast. In this screencast, I'll be going over Lab 3.5.1, Skills Integrated Challenge, Configuring Host and Services. In this lab, we were asked to add a new PC to the local area network connected to the R2 Central, as well as configure the Eagle server and connect it to the ISP's router. To begin, I will come down here to the lower left corner of my window, click on the end device, and then choose the very first icon, PC PT. Now I have this tool selected, I'm going to drop it somewhere underneath the S1 Central. To connect this PC to the switch, I need to use a straight-through cable. Remember, the rule of thumb is you use a crossover cable to connect like devices, and you use a straight-through cable to connect unlike devices. So to get the cable tool selected, I come down here, I click on the lightning bolt, and then I'm going to choose the third icon in from the right. This is the copper straight-through cable. I click once, then I'm going to click on PC0, and we choose Fast Ethernet. According to our instructions, when I click on the S1 Central, I'm going to have to connect this PC to the Fast Ethernet 0/2 port. Okay, so now I have this connected, I'm going to connect my Eagle server to a router. Although these two devices do not look like they're the same devices, technically they are. They're both computer-ish, if you will. The router acts like a computer as well as the server. Since they're similar devices, I'm going to have to use a crossover cable. To do that, once again, I'm come down here to the lower bottom of my screen, click on the dotted line, or if I hover over it, it says copper crossover. Come up here, click on Eagle server, choose Fast Ethernet, and then come over here to R1 and click. Now, once again, according to the instructions, they want me to use the Fast Ethernet 0/0. Okay, the next thing I need to do, now that I have both the physical connection for the Eagle server as well as PC0, is I have to configure the software for these devices. So let me click on PC0, and let me go up to the Config tab, and I'm asked to change the host name or the display name. So let me click where it says PC0 and remove that and type in 1B. Next thing I'm going to do is click on the Desktop tab, and then I'm going to click on the IP configuration command. Okay, I have a dot next to static because I'm manually configuring this device. And where it says IP address, I'm going to click on this box, and I'm going to type in 172.16.1.2. I got this information from the lab sheet. Now let me click on the subnet mask. I see that the computer guessed correctly. I'm going to click on the default gateway, and the address is going to be 172.16.255.254. Now the default gateway in this case is going to be represented by the R2 Central's Fast Ethernet 0/0. The lab sheet also has told me that I need to configure the DNS server. That's where the Eagle server comes in. So the address for this server is 192.168.254.254. Okay, let me close out of this. And let me close out of this dialog box for host 1B. And now let me configure the Eagle server. To do this, I'm going to click on the server, and then I'm going to come up to the Config tab, and over on the left side I'm going to turn on some services. One of the services I was asked to turn on was the web page service, or HTTP. So let me click on that service and put a dot next to on. And the other thing I was asked to configure was the DNS server. So let me click on that, and now I need to turn it on. However, just because I turn the service on doesn't mean it's actually ready to go. I need to teach the server what the domain name and the IP address for that particular domain name will be. In this particular case, I need to teach this DNS server how to access the Eagle -server .example.com. For example, if you will, if I wanted to configure this DNS server to understand about Google, I would type in for the domain name www.google.com. And now I need to map that name with an IP address. In this particular case, the IP address is going to be 192.168.254.254. So I'm actually adding an entry into this DNS. Now you can remember that DNS is like the Internet Telephone Book. It just maps a name to a number. Alright, so I turned it on, I added a record, now I'm going to close out of this. Before I actually pass data across my networks, I want to verify that I have everything properly configured. So let me come down here to the bottom of the screen, click on the Packet Tracer group icon, and click on the activity window. It says that I'm 100% complete. Alright, I like to be thorough, so I'm going to click on Check My Results. I'm going to go up to the assessment items, and I see, yes, I did establish the default gateway. I did set up the DNS server for PC 1B. I also gave it an IP address. It is connected to the switch. I used the right cable, and it has a subnet mask. When it came to the Eagle server, I enabled the DNS service, and I also established the record for eagleserver.example.com, gave it an IP address, turned on HTTP, and I connected it with the right cable to the router. Alright, let's go back to our Packet Tracer. Now that I'm back to Packet Tracer, one of the important things that Packet Tracer allows a student to do is to actually learn the theory through simulation. In the real world, when we connect a PC to a network, we should verify its connectivity by using the ping command. And the way we would do that is we click on the PC. In the real world, you would go to the PC. You'd open up your command prompt, and then you would ping another device on that network. So here I'm typing in ping space 172.16.255.254, and I'm going to hit enter. And I have replies. This allows me to know that this PC is able to communicate with other PCs on my network. Fortunately, we won't have to do that when we're in Packet Tracer. We can actually use a tool called the Simple PDU. Now, from your reading, you understand that a PDU is a protocol data unit. And what that's going to allow me to do is when I click on this envelope over here on the right side, I can click on the device that's going to send the ping, and I can click on the device that's going to receive the ping. Now, in order for pings to happen, they need to develop their ARP table. So the first time that I did this, it failed. I know it failed by coming down to the lower right corner in my little simulation or scenario area, and I can see the status source to destination has failed. Alright, let me do a new scenario, and let me try that again. This time it will succeed. So let me click on 1B, and let me click on my server, and I see it's successful. The reason behind that is in order for a ping command to work, we have to map IP addresses to physical addresses. So they have to do an ARP request. That takes a little time. The first time that I ran my ping command by using the Simple PDU, it failed because it was building up the table. The second time I ran it, the table was already built, and it was successful. Okay, let's go more into it. The idea of this lab was to teach you how services work. So in Chapter 3, you're learning about applications and services. Clients use applications to access service. Earlier, I set up DNS and the HTTP service on the Eagle server. And I also configured the PC so it can communicate to the outside world. So in the next example, I'm going to be using a web browser, which is going to be the client's application to access a web service on our Eagle server. But before I actually start executing these commands, I'm going to change my mode. I'm going to change it from real time to simulation. To do that, I come to the right part of my screen, the lower right corner, and then I'm going to click on the little stopwatch. Next, I'm going to delete my scenario, so I have a fresh scenario, deleting both of them. So it said scenario 1, I deleted it, scenario 0, deleted it. Now I'm back to an empty scenario. As you can see, my event list cleared out. Now, I'm going to come over here to the PC 1B. I'm going to come up here to where it says web browser. By the way, if you don't have that on your screen, you have to click on the desktop tab. Then come over here, click web browser. And then in the URL, I'm going to type in eagle-server.example.com. I'm going to click go, but nothing's going to happen. Since I'm in simulation mode, it actually will freeze frame this. I'm going to minimize this for a second. I can see it's right here, 1B. And then over here, I have the little DNS event. Well, let me explain what's going to happen. Before a web browser can communicate with the web server, the web browser needs the web server's IP address. You and I don't work very well with numbers. We like names. So we typed in a name. Now the web browser needs to resolve that name, the eagle-server.example.com, into an IP address. And that's when DNS comes in. Let me come over here and click on this color square to learn more about DNS. I'm going to click on the outbound PDU details, and I'm just going to scroll down to the bottom. These are all the OSI layers coming into effect, and I can see that we are asking a question. In fact, this is called a DNS query. I am asking what is the IP address for this name? I don't have an answer yet. So the first thing is a DNS request. So let me hit play. First of all, I'm going to speed this up a little bit. And when I hit play, this packet should go to the server. The server should pass it to my router. The router should pass it up to this router. And this router should pass it up to the server. The reason why that's happening is because I configured the 1B PC to have a DNS address of 192.168.254.254. Okay, I paused it. The way I paused it was clicked on the play button again. Now I got a response coming back from the server. So when I look over the event list, I can see that the last device was the Eagle server and it's heading to the R1 ISP. Once again, let's click on that DNS square. This time let's click on the outbound PDU and let's scroll down and we'll see what's coming back to my user. Do you see I have a DNS answer now? The query was right up above. The answer is underneath it. So I'm telling the end device who made this request that the IP address for this server is 192.168.254.254. The packet's being sent back. In order to get back there, it has to go to this router, then it has to come back down to this router, over to the switch, and back to the PC. If all goes well, when the PC gets it, it'll finish executing its HTTP request. So the packet should change color, creating a new event, and that event should represent an HTTP request. And here we are. So I paused this, and it's waiting to go because it's building up the information that they needed. And you can see I have a new color. It's purple this time. Let me open it up. Let's look at the outbound detail. And what this should be is HTTP request. I'm asking for a web page. So when I scroll down, look at the layer 7, the application layer, I am making an HTTP. In fact, it's called the GET command for this reason. I'm getting in the index page from the server. Alright, let me close out of this and let's watch this journey occur. So it's building up, making that request, and eventually it'll kick up to go to the switch. From this switch, it'll go to this router. The router will pass it to this router and then over to the server. The server should respond, which we call an HTTP response, with the actual HTML data. So once this server sends out the response, I'm going to pause it. I'm going to come back to my event list, and I'm going to click on the one that says from Eagle server to R1 ISP. Let's click on that. Look at the outbound details. I'm going to scroll down, and you can see I have the HTTP data. Now I know this data is HTML because this line says content type HTML, which plain English is just a web page. Let's close out of that. Now I'm going to hit play, and when I do, I'm going to bring up my dialog box that represents 1B, and when this PC receives this packet, the web page should now be displayed in the web browser. And there it is. So in this lab, we learned a couple of things. We learned how to connect a PC to a network, how to configure that PC so it belongs to that network, how to connect a server to a router, how to establish its services for that router, and more importantly, how a web browser uses DNS to relay or translate information between names and IP addresses.